Good evening, student. Myself, ARUNAV Chatterjee, Faculty of Chemistry. In today's class, I am going to describe different types of organic reaction. As you know that in your earlier classes, you have studied that organic reactions are of various types, but three main types of organic reactions are addition reaction, substitution reaction, and elimination reaction. And other than this, there are some more types of reaction which are known as rearrangement reaction, pericyclic reaction, and condensation reaction. In this particular series of organic chemistry lecture, we will touch all the types of reaction with their mechanism. So first I'll start with the addition reaction. What is addition reaction? Let's see. Addition reaction. The meaning of addition reaction is simply the attachment of the atom or group from the reagent molecule to the reactant molecule. And addition reaction mainly shown by the unsaturated organic compound. For example, CH2 double bond CH2. This is ethene and it reacts with hydrogen in presence of nickel at the temperature 250 degrees Celsius to 300 degrees Celsius. What we have to do, we just need to add both the hydrogen atom with double bonded carbon atom, and during the reaction double bond become single bond and the product will be CH3 bond CH3. This is ethane. Such type of reaction is known as addition reaction, and in this type of reaction the reagent molecule attach simply with the reactant molecule without the removal of atom or group from the reactant molecule. So it is an example of addition reaction. Similarly, if we consider another example, CH3 CH double bond CH2. This is propene, and the reaction of propene with hydrogen under similar condition, we have to notice the part of alkene where the double bond is present, and simply we need to attach the hydrogen atom. This becomes CH3 CH2 CH3, and this is N propane, stands normal propane. So such type of reaction in which the atom or group of a reagent molecule simply added with the reactant molecule without the removal of atom or group from the reactant molecule, known as addition reaction. And addition reaction mainly shown by the unsaturated organic molecule, and after the reaction they form the saturated product. And we can classify this reaction in this way also, that we are adding hydrogen as a reagent to an alkene molecule. So this reaction, addition of hydrogen, is also known as hydrogenation reaction. So we can say that hydrogenation reaction is also an example of addition reaction. Now, there are some types of addition reaction, and those are following. The first one is electrophilic addition reaction. By the name, it is quite clear that the electrophilic addition reaction takes place by the help of electrophilic reagent. Second is nucleophilic addition reaction. Nucleophilic addition reaction. And third one is free radical addition reaction. Free radical addition reaction. So addition reactions classified into three main categories, which are electrophilic addition, nucleophilic addition, and free radical addition. The addition reactions which takes place by the help of electrophile reagent known as electrophilic addition reaction. Similarly, the reactions which are taking place by the help of nucleophile known as nucleophilic addition reaction, and those which are carried out by the help of free radical known as free radical addition reaction. Now we need to understand that what type of reactant molecule showing electrophilic addition reaction, nucleophilic addition reaction, and free radical addition reaction. Electrophilic addition reactions mainly shown by alkene and alkyne. Mainly shown by alkene and alkyne. They have double bond or triple bond between their carbon atoms. So, they are also considered as unsaturated organic compound, rather we can say the hydrocarbon. So the unsaturated organic compound or unsaturated hydrocarbon having tendency to show the electrophilic addition reaction. Now the second one is nucleophilic addition reaction. Nucleophilic addition reaction mainly shown by the carbonyl compound. Carbonyl compound. And what type of compounds are known as carbonyl compound? The compound which consists of carbon oxygen double bond are known as carbonyl compound. And there are many carbonyl compounds are known, in which two are most important one, which are aldehyde and ketone. And the last one, free radical addition reaction. Such type of addition reaction shown by the alkene. So we have already discussed addition reaction and its example and types of addition reactions, which are electrophilic, nucleophilic, free radical addition reaction. With their examples, in short form, we have already explained that the unsaturated organic compound having tendency to show the electrophilic addition reaction, and the carbonyl compound which consists of carbon oxygen double bond have tendency to show the nucleophilic addition reaction, and so on, alkenes having tendency to show the free radical addition reaction. Now we are going to discuss about the types of addition reaction in detail. In today's class, I will explain about electrophilic addition reaction. It will be more easily explained by the example that we are taking over here. So let's see how the electrophilic addition reaction is taking place. For example, we are taking propene and this propene is unsymmetrical unsymmetrical alkene. Now the question is, why it is unsymmetrical alkene? Because the carbon-carbon double bond consists unequal number of hydrogen atom. The right side carbon atom consists of 2 hydrogen and the left side consists of 1 hydrogen, and when it reacts with HCl, H carry positive part and Cl carry negative charge. So it is reagent, and this reagent is also unsymmetrical. And during this reaction, a law is applied over here, that is Markovnikov's addition. And this law states that the positive part of the reagent, added to that side of the double bond carbon which carry maximum number of hydrogen atom, and the negative part is added to that side of double bonded carbon atom which carry minimum number of hydrogen atom. So we can add hydrogen of HCl in the right side carbon, double bonded carbon of alkene, and we can add Cl to the left hand side of double bond carbon atom of alkene, and the product will be CH3, Ca, Cl and CH3. It is 2-chloropropane. It is 2-chloropropane, and it is an example of 2-degree haloalkane. Now, if you want to know why it is called 2-degree haloalkane, let us consider the halogen atom, that is chlorine, and this halogen is attached with this carbon, and this carbon is attached with 2 adjacent carbon. So it is 2-degree haloalkane. Now we want to see that whether the reaction is electrophilic addition reaction or not. It is also an example of addition reaction because nothing is changed in the reactant side, but after the reaction there is a attachment of hydrogen and chlorine from the reagent to reactant molecule. So the product which are obtained at the end of the reaction known as addition product. Now try to understand the mechanism of the reaction can be explained under the following steps. Step 1, I am notifying the step 1 by using this dot. Step 1 involves the formation of electrophiles. So see how the electrophile is generated. HCl get ionized into H plus and Cl minus, and then this alkene interacts with the H plus. There are 2 possible sites where hydrogen ion can attach. The pi bond electron shifted from here because there is a double bond, one bond is sigma and another one is pi. So hydrogen can attach both of these double bonded carbon atom. Let's see what happens. If we attach H plus in the left side double bonded carbon atom, then we are getting this, and the last carbon has consist of 3 bonds, which means it will carry positive charge, and C plus is attached with 1 adjacent carbon, so it is 1-degree carbocation. This is 1-degree carbocation, And if we attach the carbon, if we attach the H plus ion to right hand side of the double bonded carbon, then we are getting this carbon is electron deficient middle carbon, so it will be 2-degree carbocation. And as we know that higher degree carbocation is always stable, so we have to choose those carbocation or that carbocation which are of the higher degree. So we can't consider this one, and this state is slow state. And since the carbocation also has tendency to accept the electron, in this particular case carbocation considered as electrophile. Carbocation considered as electrophile. And in the last step, what we need to do, we have to consider the carbocation of higher degree, and it is interact with the Cl minus ion, and this is very fast state. Cl minus readily interacts with the electron deficient carbon and it forms the product. So we have discussed today addition reaction and its different types of addition reaction, and in today's session we have explained electrophilic addition reaction, and also we have explained another very important topic, that is Markovnikov's addition. Many a time a notes is given in your examination that you have to write down the notes on Markovnikov's addition. So you can write that whenever an unsymmetrical alkene is treated with unsymmetrical reagent, then the positive part of the reagent is added to that side of the double bonded carbon atom which bears maximum number of hydrogen atom, and the negative part is attached to that side of the double bonded carbon atom which bears minimum number of hydrogen atom. And this is explained by Markovnikov, so it is known as Markovnikov's addition. And after every addition reaction, the unsaturation become converted into the saturated product. So in our next segment, we will discuss about another type of addition reaction, that is nucleophilic addition reaction. Till then, goodbye.